There is a moment in every Apollo documentary where the narrator says, "And then we stopped going," and the audience nods along, as if that's a reasonable thing for a spacefaring species to have done. It isn't. We reached another world, stood on it 6 times, looked back at the Earth from 250,000 miles away, and then made a collective decision that we had seen enough. But why? For 50 years, the most powerful nation in the history of space exploration pointed its best rockets at low Earth orbit and called it ambition. It just doesn't make sense. That all ends in 2026, and what replaces it isn't a flag-planting exercise, it's a construction project that won't be finished in our lifetimes. This is how NASA builds a permanent city on the moon. The first mission, Artemis 2, ironically scheduled on April 1st, its job description is almost insultingly modest given what it costs. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, climbed aboard the Orion capsule, rode the Space Launch System out of Earth's atmosphere, loop around the moon, cross the far side, where no radio signal can reach them for 40 minutes, and come home. No landing, no moonwalks, no Buzz Aldrin moment. Just 10 days in deep space to prove the rocket works, the capsule works, and that the heat shield can protect a human crew during re-entry at temperatures above 5,000 degrees Fahrenheit, which is hotter than the sun's outer surface, burning away the shield material in a controlled sacrifice to keep the people inside alive. The estimated operational cost of this proof of concept, you ask? Approximately $4.1 billion for a single launch. That number is not a typo, folks, and that doesn't include the cost of actually building the rocket either. So it should tell you something important about the stakes of everything that follows. At that price per flight, there is no room for a program that doesn't build towards something permanent. Artemis 2 has to work, and what comes after it has to work. Because if Artemis becomes another Apollo, a series of brilliant individual missions that quietly loses funding, momentum, and purpose, then we spent $4 billion to prove a point and went home again, this time without a bag full of moon rocks. And history will not be so kind about that, I'm sure. So if Artemis 2 is the proof, then Artemis 3 is the primary mission, and getting to the surface requires solving a problem that didn't exist in the Apollo era. The Orion capsule cannot land on the moon. It's a deep space transport vehicle, not a lander. For the surface, NASA chose to collaborate and opted for a modified version of SpaceX's Starship, the largest rocket ever built, purpose-designed for the lunar South Pole, equipped with a massive elevator to carry crew the 100 feet from the hatch down to the surface. But Starship has a problem that is fundamental to its design. It is so large, so heavy, so fuel-hungry, that it is physically impossible to launch it to the moon on a full tank. No rocket powerful enough to lift it fully fueled actually exists. They've unanimously decided that the fuel has to get to the moon in a different way. What NASA and SpaceX are proposing is designed to solve one of the most complex logistical operations ever attempted in the history of spaceflight. Before the lander ever flies to the moon, a fleet of robotic tanker spacecraft launches into low Earth orbit and begins assembling a fuel depot in space. Yep, a floating gas station that fills up gradually, launch by launch. Each tanker docks, transfers its cryogenic payload, liquid methane and liquid oxygen, kept at temperatures approaching minus 180 degrees Celsius, and returns to Earth to be refueled and launched again. This process is not straightforward. Cryogenic propellant in microgravity behaves in ways that don't exist in any ground test environment. The fluids want to float, to slosh around, to vaporize in the wrong places at the wrong times. A single failed seal on a transfer coupling, and the entire floating depot mission is compromised. The lander can't leave without a full tank. The crew can't launch until the lander is waiting. So every launch in the sequence depends on every launch before it going exactly 100% perfect. Think about it. A dozen launches, hundreds of orbital maneuvers, all just to get one ship fueled and parked on the moon before the crew even leaves Earth. If that sounds excessive, consider the alternative. And the alternative is simply, don't go. This is what's involved in actually going. When the depot is finally full, the lander launches alone on its robotic voyage to lunar orbit, where it waits alone in silence for the crew. Then Artemis 3 launches. Orion carries the crew to the moon, rendezvous with the waiting Starship lander in one of the most precise docking maneuvers ever attempted, a small capsule linking up with a 100-ton skyscraper, 250,000 miles from home in the dark, with no margin for error. 2 of the 4 crew members transfer across. The hatch seals, the lander separates from Orion, and the final 100-mile descent to the lunar surface begins. The landing is entirely automated. The ship scans the terrain, identifies the safest available touchdown point, and fires its engines in a precisely calculated sequence to set itself down on the surface. In the final seconds, the engines throttle down until they are barely holding the vehicle aloft, and then the landing legs make contact with the lunar regolith for the first time. The engines cut, and there is silence. For the first time since December 19th, 72, more than 50 years, human beings are standing on the moon. Not in a simulation, not in a training facility, but on the actual surface of the moon. That is not a routine achievement dressed up with adjectives. That is one of the rarest things our species has ever done. And the people who pulled it off will have spent the better part of a decade making it look like it was always going to work. Now here is where the Apollo story ends and something entirely new begins. The target for Artemis 3 is the lunar South Pole, and the choice of location is the single most consequential decision in the entire Artemis architecture. The South Pole is not chosen for orbital convenience or terrain flatness. It's a specific region selected for one reason above all others, a location believed to contain something that changes everything about what we know that the moon can potentially become. Hiding in the permanently shadowed craters at its base, craters where sunlight has not reached in billions of years, where temperatures drop to minus 250 degrees Celsius, ancient water ice has been sitting undisturbed since the early solar system. The crew deploys instruments, sensors drill into the regolith, and then the confirmation arrives. Water ice found just meters below the very surface they're standing on. Sit with that for a moment, because it is easy to hear water ice on the moon and file it away as an interesting geological fact. It is not. Water ice at the lunar South Pole is the single most important discovery in the history of human space exploration since we first left Earth's orbit. Because water ice on the moon is not just water. Split it with electricity, and you have oxygen. Real breathable air produced from local resources without a single resupply from Earth. Split it further, and you have hydrogen, which combined with locally sourced materials becomes rocket propellant. The same process that on Mars produces methane for Starship, adapted for the lunar environment, produces the fuel that lets a spacecraft launch from the moon's surface and reach orbit. Water ice means air. Water ice means fuel. Water ice means a closed loop, a self-sustaining outpost that doesn't need Earth to keep it running. It means, in the most literal sense possible, that a city on the moon is no longer theoretical. It is an engineering problem with a known solution. That confirmation, coming back through the instruments while the crew stands in the dust at the lunar South Pole, is the moment the mission crosses a threshold that no flag planting, no rock collection, no television broadcast ever could. Before the crew leaves, they deploy the first permanent structure on the lunar surface, a small inflatable habitat, pressurized, lit, functioning. By any earthly standard it is unimpressive, but by the standard of what it represents, the first human-built structure, designed to remain on another world indefinitely, the first brick in a city that will outlast everyone who built it. Well, there is simply just nothing like it in our history, folks. 7 days on the surface, a week of science, construction, and learning what an alien environment does to human bodies and equipment up close. The lesson that surprises people most is always the dust. Lunar regolith bears no resemblance to Earth soil. Formed over billions of years without wind or water erosion, the particles are not rounded like ours are. They're jagged, microscopic shards that behave like crushed glass, aggressively abrasive, electrostatically charged, and clingy in ways that defy every intuitive expectation. The Apollo astronauts dealt with it for 3 days and came home with suits that looked like they had been sandblasted. The crews who follow will be dealing with it for weeks, then months, then years. It coats sensors, degrades seals, infiltrates life support connections, and has no satisfactory solution yet. Of all the engineering problems Artemis faces, lunar dust is the one that refuses to be fully engineered away. But there's a philosophical difference between Apollo and Artemis that is the unique key to the space travel log, something that doesn't get anywhere near the attention it deserves. Once the mission nears its end, the crew launches the lander from the moon surface for refueling. The first ever launch of a vehicle this size from another world back up to the galaxy's first ever floating gas station. Orion is prepared and the crew comes home. But the lander stays in orbit, ready and eagerly waiting for the next crew to arrive. Nothing is thrown away. The hardware accumulates and the infrastructure stays. Apollo was a series of individual missions, each one complete in itself, leaving almost nothing behind for the next. Artemis, however, is a construction project. Every crew builds on what the last crew left. The inflatable habitat gets joined by more modules. A pressurized rover arrives. A mobile home capable of extending exploration hundreds of kilometers from the base. A lunar gateway station takes shape in orbit. A permanent staging point beyond Earth's atmosphere that gives every future mission a place to dock, resupply, and prepare. The base at the South Pole grows, mission by mission, into something that earns the word permanent. And then, at some point in the missions that follow, the moon stops being the destination. Here is the honest truth about what the Artemis program is built around. The moon is a rehearsal. Everything happening on the lunar surface, the in situ resource utilization, the closed-loop life support, the construction with local materials, the management of systems that cannot be resupplied quickly from Earth, is all practice for a place 8 months away, where the consequences of getting it wrong are final. Every problem solved on the moon is a problem that doesn't kill someone on Mars. The South Pole becomes a refueling station. The gateway becomes a departure point. The technologies proven in lunar gravity, in lunar vacuum, in lunar dust get packed into the ships that follow the sun, outward. The moon is not the destination, folks. The moon is how we learn to reach the destination. But that framing, useful as it is, undersells what is actually being built here. Because the moon has value in its own right that has nothing to do with Mars. A permanent lunar base at the South Pole, with access to water ice and near-continuous solar power on the crater rims above, is also the foundation of the first off-world economy. Oxygen and propellant produced from local resources, which might explain the apparent race to get there. Scientific research conducted in conditions that cannot be replicated anywhere on Earth. A platform for astronomical observation above the noise and atmosphere of our home planet. The moon is not a stepping stone to be used and discarded. It is the first address in a neighbourhood that does not yet exist. We went back to the moon not because it was easy, and not because 50 years of waiting made it feel overdue. We went back because we finally understood what it was actually for. Not a destination to visit, no longer a record to set, but a solid foundation to build on. The first permanent human presence beyond Earth, constructed mission by mission, problem by problem, in the dust of a world that has been waiting 4 billion years for someone to finally decide to stay. The journey began on February 6, 2026. For the first time in human history, the plan is not to come home and leave it behind. The plan is to stay until it feels like home.